Hello everyone, welcome to this lecture. I am Amlan Das. Today I will discuss about Meissner effect. Okay. When a normal conductor whose temperature is greater than critical temperature Tc. When a normal conductor is placed in an external magnetic field, it is observed that the magnetic flux or the magnetic lines of force enters into the material. That is, the magnetic lines of force penetrates into the material. Okay. So this is for normal conductor for temperature T greater than Tc. Okay. But when a superconductor whose temperature is less than critical temperature Tc, okay, when a superconductor is placed in an external magnetic field, it is observed that the magnetic flux or the magnetic lines of force is expelled from inside the superconductor. Okay, that is, the magnetic flux does not penetrate into the material, and the magnetic lines of force looks like this. Okay, so this is for superconductor for T temperature T less than Tc. Okay, this phenomenon was first observed by two scientists, Meissner and Rosenfeld. In 1933, after extensive studies on the magnetic properties of superconductors, Meissner and Rosenfeld observed that when superconductors are cooled below their critical temperature Tc and is placed in an external magnetic field, the magnetic flux or the magnetic lines of force is expelled from interior of the superconductor, and it behaves as a perfect diamagnet. This phenomenon of flux exclusion below their critical temperature Tc by the superconductor is known as Meissner effect. Okay. So Meissner effect shows perfect diamagnetism property. Okay. Now let us see mathematically how superconductor behaves as a perfect diamagnet when it is placed in an external magnetic field. Okay. We know that the magnetic field B is equals to mu 0 into H plus M. Okay. We know that the magnetic field B is equals to mu 0 into H plus M, where mu 0 is the permeability of free space. Permeability of free space. H is the magnetic field strength. Okay, H is the magnetic field strength. Magnetic field strength, and M vector is the magnetization, that is intensity of magnetization. So M is the intensity of magnetization. Okay. Now for T less than Tc, for temperature T less than critical temperature Tc, inside the superconductor, we have B vector equals to 0. Okay, inside the superconductor we have magnetic field B equals to 0. So from this equation we get 0 is equals to mu 0 into H plus M. Okay. Or H plus M is equals to 0, since mu 0 is not equals to 0. Okay. Hence we get H vector is equals to minus M vector. Okay. So the magnetic susceptibility. So the magnetic susceptibility chi is equals to M by H, and this is equals to minus 1. Okay. So we get magnetic susceptibility is chi is equals to minus 1, and it corresponds to perfect diamagnetism. Okay. So this corresponds to perfect diamagnetism. Thus we saw that inside the when a superconductor whose temperature is less than critical temperature is placed in an external magnetic field, the magnetic flux is expelled from inside the superconductor and it behaves as a perfect diamagnet. Okay. And this is Meissner effect. Okay. Thank you for watching this video.